Welcome back, students. This is the Q&A session 19 from the playlist of work, power and energy. The topic is the total mechanical energy, and based on this topic I have taken one question from one of my reference books. The question is, the potential energy of a body of mass 1 kg moving along the x-axis is given by this formula, that is V is equal to x to the power 4 divided by 4 minus x to the power 2 divided by 2 joules. So the maximum velocity of the body in meter per second, if the total mechanical energy of the body is 2 joules, is. So here we have been given 4 options and we have to find the correct one. Now we know that the total mechanical energy of a body is equal to the sum of the kinetic energy plus the potential energy. Now this formula can also be written as the sum of the maximum kinetic energy plus the minimum potential energy, and this formula can also be written as the sum of the minimum kinetic energy plus the maximum potential energy. Whenever a body is having the maximum kinetic energy, then it will be having the minimum potential energy, and whenever a body is having the minimum kinetic energy, then it will be having the maximum potential energy. So this equation can also be written in this form. Now here we have to find the maximum velocity. So the maximum velocity can only be found if we know the maximum kinetic energy of that body. Now if the body has got the maximum kinetic energy, then at that moment of time it will be having the minimum potential energy. So in this question, the potential energy of the body is given by this equation, that is V is equal to x to the power 4 divided by 4 minus x to the power 2 divided by 2 in joules. Now it means that the potential energy of this body is varying with the displacement of this body. Now we have to find right now the minimum potential energy of this body. Now in order to find the minimum potential energy of this body, what I will be doing is I will be differentiating this equation with respect to x. And why I will be doing it? See, when the body attains a minimum potential energy, then it means that the potential energy of that body will not decrease beyond that minimum value. So in this case, if I differentiate this potential energy with respect to x and put it equal to 0, then I will be getting the value of x at which the potential energy of that body will be minimum. Now when the potential energy of a body is minimum, then the rate of change of this potential energy with respect to this displacement in this case will be equal to 0, because the potential energy is not going to decrease beyond decrease below the minimum value with this displacement. So or we can say, in other words, we can say that the rate of change of the potential energy with respect to the displacement will be equal to 0 in the case of the body having the minimum potential energy. So if I differentiate this body with respect to x, I will be getting this value as x cube minus x, and I will be putting it equal to 0 because the rate of change of the potential energy with respect to the displacement in this case will be equal to 0, because the potential energy is not going to decrease beyond the minimum potential energy. So from here I will be getting this equation that x in bracket x square minus 1 is equal to 0. Now From this equation, the value of x will be equal to 0. Now x square minus 1 can be written as x square minus 1. See, this equation, this value will be equal to 0 when x is equal to 0 or x square minus 1 is equal to 0. Now x square minus 1 is equal to x minus 1 into x plus 1, and this is equal to 0. So this will be 0 when x is equal to 1 and x is equal to minus 1. So the values of x which I am getting from this equation is 0, 1 and minus 1. So now what I will be doing is, I will be now finding the value of the potential energy at these values. So at x is equal to 0, V will be equal to 0. At x is equal to 1, V will be equal to 1 by 4 minus 1 by 2. This is equal to minus 1 by 4 joules. And at x is equal to minus 1, V will be equal to again minus 1 by 4 joules. Now, the total mechanical energy of this body is 2 joules. So I will be using this equation, that is total mechanical energy is equal to the sum of maximum kinetic energy and the minimum potential energy. Now the total mechanical energy is given as 2 joules. The maximum kinetic energy is to be found out, and plus the minimum potential energy, which is equal to minus 1 by 4 joules. So from this equation, the value of the maximum kinetic energy will be equal to 2 plus 1 by 4. So this is equal to 4 plus 2, 8 plus equal to 9 by 4. Now kinetic energy is equal to half m v square, and this will be equal to 9 by 4. So from here, this will get cancelled out, and the value of the mass of this body is 1 kg. So v square will be equal to 9 by 2, or simply we can say that v is equal to 3 upon root 2 meters per second. So the correct option is B. So in this case, or in this question, the most important thing was the selection of the equation from these, from the three equations which I have written just a few minutes back. So the total mechanical energy is equal to the sum of the kinetic energy plus potential energy, but this is also equal to the sum of the maximum kinetic energy plus minimum potential energy, and this is also equal to the sum of the minimum kinetic energy and the maximum potential energy. So here in this question I have used this equation, that is the total mechanical energy is equal to the sum of the maximum kinetic energy and the minimum potential energy. Now, in order to find the maximum velocity, we have to find the maximum kinetic energy, and for that I have to find the minimum potential energy, because the total mechanical energy is equal to the sum of the maximum kinetic energy and the minimum potential energy. So the for finding the minimum potential energy, I have differentiated this equation with respect to x. Then I had found the value of x at which I have found the values of the potential energy, and out of that I have found the minimum potential energy which was substituted in this equation. So by substituting that value of, that is by substituting the value of minimum potential energy in this equation, we found the value of maximum kinetic energy, and thereafter we were able to find the maximum velocity, which was equal to 3 upon root 2 meter per second. So thank you very much for joining this session. In the next session, I will be coming with a different topic on the same chapter, that is work, power and energy. So till then, have a nice day. Bye.